In this lesson, we are going to start talking about functions. So this is our introduction to functions, and this will be part 1. So our objectives are to understand functions, and then we'll learn to identify the domain and range of a function given a graph or ordered pairs, and then we'll be able to write the domain and range in interval notation. So there are a couple definitions of functions that I like to go over and discuss. The first one is that a function is a correspondence between a first set called the domain and a second set called the range. So we have one set and another set, and there's some type of correspondence between them, such that each member of the domain corresponds to one member of the range. So for instance, if we're thinking of a graph in x and y, every x value only has one y value. Okay, x values, you can't have two different y values for the same x value, or two different elements in the range for the same element in the domain. Okay. Another way to think about it is, given a relation x and y, we can say y is a function of x if for each element in the domain there is exactly one element in the range. Okay, so again, another way to think about this is for each x or element in the domain there is one y. Okay, so you'll be given functions in a couple different ways, sometimes as a column with some lines showing the relation, or sometimes as a graph. Okay, so first determine whether the correspondence is a function. So we have part A and part B. We'll start with part A. The domain, the elements in the domain are 1, 3, 4, and 5, and the elements in the range are A, M, L, and Q. These arrows are showing us which element in the domain corresponds with which element in the range. So let's just talk about that for a minute. So 1 corresponds with L, 3 goes to A, 4 goes to Q, 5 goes to M. So when we're determining whether this is a function or not, we want to make sure that each element in the domain only goes to one element in the range. So 1 only goes to one element, 3 only goes to one element, 4 only goes to one element in the range, 5 only goes to one element in the range. So this is a function. Okay, now let's move over to the domain. In part B, so the domain is F, G, H, capitals, and we have for the range 1, 11, 17, and 15. So in order to determine if this correspondence is a function, we need to make sure that each element in the domain only goes to one element in the range. So F goes to 17, G goes to 1 and to 15. Okay, so G, this would be one element in the domain is going to two elements in the range, so no, not a function. Okay. I'm going to go back over to part A and add something on here. Let's say we added 6. Okay, 6, let's say it goes to M. This would be okay. You could have two different x values going to the same y value. What you can't have is the same x value going to two different y values. Okay, so for one x, there's only one y. These are two different x's even though they're going to the same y value. Vertical line test. So when you're given a graph of a function, we can use the vertical line test to determine whether the given relation is a function. Okay, so I should say when you're given some type of graph, you can determine whether the relation presented on that graph is a function or not by the vertical line test. So what you do is you draw vertical lines through the relation that you're given on the graph, and if the relation only touches the vertical line once for every vertical line, then it's a function, because that's telling us that for each x there's only one y. If the relation touches the vertical line more than once, then it's not a function. Okay, so let's see what that looks like. So part A, we'll draw vertical lines. It touches once, touches once, touches once. Okay, and you can envision drawing infinitely many vertical lines. It's only going to touch each vertical line once. So yes, this is a function. Okay, if we go to part B and we draw vertical lines, right away, this touches the vertical line twice, so it's not a function. Okay, and again, this is the same x value, -2, and it's going to two different y values instead of just one. So that's what makes it not a function. So now we're given ordered pairs. So these braces here this is set notation, so we have a set of ordered pairs. We have 1, 2, -2, -4, 5, 10, -3, -6. So again, we're looking at each x value only has one y value. So our x values, we have 1, -2, 5, -3. Okay, so we don't have duplicate x values. We're probably safe. One way that you can do this too, and the reason I put a graph, is you can graph these ordered pairs and see if it passes the vertical line test. And -3, -6. So if you were to connect these, we would have a straight line. It would pass the vertical line test. So yes, this relation is a function. Okay. Going down to part B, we have our x values, or our elements in the domain is 5, -2, 5. We have two x values here, okay, and they're going to different y values. So this would make this not a function. And I'm going to graph this in blue. So 5, 2. And then we have -2, 1. And then we have 5, -3. And then we have -3, -1. Okay, if you connected these somehow, you could see, let me draw it in a different color, that it would not pass the vertical line test here because it would touch the relation at two different points instead of just one. Okay, so some different ways that relations are presented in order to determine if the relation is a function or not. Let's go on to domain and range. Okay, so domain, the set of x values is called the domain. So all of the x values of a function are called the domain. Okay, you can have the domain written in set notation, and this is for if a function is discrete or has distinct x values or elements of the domain. Or sometimes we'll write it in interval notation if it's continuous, or if there's, if you've got a line where there's infinitely many points, it's best to write it in interval notation. And the set of y values is called the range. So again, that could be written in set or interval notation. Okay, so first determine whether the given relation defines a function and give the domain and range. So here we have January we have a table, so we have the month and then the number of visitors in Las Vegas. So in January, there were over 3 million visitors. In February, there was over 3 million visitors. And then in April, there were 106,000 visitors. Okay, so because for each x, there's only one y, this relation is a function. Okay, and in this case, we would write the domain in set notation because we have three distinct elements in the domain. We have January, which I'm going to abbreviate for the sake of space, February, and April. Okay, for the range, we also list each element in the range in set notation again because there's three distinct elements. So we'd start with our braces and we would write each number separated by commas. Okay, and I'm going to try to write the commas in between the numbers as big commas to see the difference between the commas and the numbers. There should be a 0 there. It's not coming up. Or maybe I ran out of room. Let me go ahead and put this on here. Okay, so we've got the domain and range, and we've determined that this relation is a function. Next, determine the domain and range of the relation and tell whether the relation is a function. So now that we have a relation here, we can use the vertical line test. So imagine drawing vertical lines. The relation would touch the vertical line at only one point. So yes, this relation is a function. Domain, we go left to right. And so now since we don't have discrete values, and by discrete, I mean if we had, set dots on the graph, but in this case, our domain would cover everything from -4 to 2, and we'll talk about the open and closed circles in a moment, but what that means is -3.9, -3.8, -3.7, and everything in between. So there are infinitely many elements in the domain, so this is where we would use interval notation. Okay, so domain is left to right, or smallest to biggest. There's a closed circle here, which means that this is going to get a bracket for interval notation because the endpoint is included. There is a point at -4. Going to the right, let me erase some of what's on here. We have an open circle at x is 2, which means that this function goes all the way up to 2, like 1.99999, but 2 is not included. So 2 gets a parenthesis, and it has to be written like this. It cannot be written as this. Okay, it has to be smallest to biggest. So now let's move to the range. The range is the lowest y value to the highest y value. And for range, we're looking at y's. So the lowest y value is -2, but it's not included, so it gets a parenthesis. And the highest y value is 4, and that gets a bracket. Let's do another example. So determine the domain and range of the relation and tell whether the relation is a function. So again, we use vertical line tests, okay? And the relation touches the vertical line only one time, which means that yes, this relation is a function. Domain, again, left to right value, smallest to biggest, but domain is x. Okay, so our smallest x value is -2, and that is included since there's a closed circle there. And we go all the way to 3, and that gets a parenthesis because that endpoint is not included, but everything up to 3 is. The range is the lowest y value to the highest y value. Now the lowest y value is -5, and since there's not an open circle there, since there's a filled in line, -5 is included, and 4 is included as well, okay, because there is a closed circle there. Example 4, graph the function, and then visually estimate the domain and range. So we have f of x, which is function notation. Something we haven't talked about yet, but we will, is that y is equal to f of x. So this function is a line. It's in the form of y equals mx plus b, where b is 2 and m is 3 or 3 over 1. So let's graph this first. So we would start at 2, and then we'd use our slope, 1, 2, 3 over 1, 1, 2, 3 over 1, okay, to draw our line. And this line would keep going forever and ever. We don't have any restrictions. So when it comes to domain and range, if you follow the x values lower and lower, it's going to keep going down, 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 farther, okay? And so this would be -infinity. Okay, infinity always gets a parenthesis because you technically can't stop there. And we would go all the way up to +infinity because this graph is going to keep going. It's going to have more and more x values, bigger and bigger x values. Okay, the same thing is happening for the range. The lowest y value, if we keep going down, is -infinity. And the highest y value, if we keep going up, is +infinity. Okay, so this is how we would visually estimate the domain and range. Thank you for watching. We'll continue on about functions in our next lesson.